Welcome to Daily Papers.
Imagine a rescue robot navigating through the debris of a collapsed building, or a self-driving car cruising down a busy street. These machines are constantly taking in video, and they need to understand what's happening right now to make critical decisions.
Exactly. They can't wait until the end of the movie to figure out what the important parts were. Most of our current AI for video understanding is great at making highlight reels for a sports game that's already finished. They can watch the whole thing, rewind, fast forward, and then pick out the best moments.
But that's a luxury a robot in a disaster zone doesn't have. It needs to find the highlights, the important stuff, in real time as the video is streaming. And that brings us to today's paper.
This is AHA, Predicting What Matters Next. Online Highlight Detection Without Looking Ahead by researchers from the University of Southern California and the DevCom Army Research Laboratory.
The title really says it all. Can we build an AI that can find the important moments in a video without getting to peek at the future? The authors call this online highlight detection, and their solution is a model they named AHA.
So, how does it work? Most AI models that summarize videos are offline. They download the entire video file, process it all at once, and then give you a summary. They have full context. AHA works online, meaning it processes the video frame by frame as it comes in.
It's like the difference between a sports analyst writing an article after the game is over versus a live commentator calling the plays as they happen. The live commentator has to make instant judgments with incomplete information. That's what AHA is designed to do.
You give AHA a video stream and a task in plain English. For example, you might tell it, find the moment the delivery driver drops off the package. Then, as your security camera streams video, AHA watches each frame and decides how relevant it is to that task.
And what's really cool is that it's not just making one simple judgment. The model has what the paper calls multiple prediction heads. You can think of them as a panel of expert judges, each looking for something different.
Right. The first judge is the relevance head. This one is focused purely on the task. For every single frame, it asks, does this frame show the delivery driver dropping off the package? Yes or no?
The second judge is the informativeness head. This one is looking for novelty. It asks, is this something new and interesting? For example, if the camera is just staring at the empty porch for 10 minutes, that's not informative. But the moment a person walks into the frame, that's new information.
And the third, which is a really clever addition, is the uncertainty head. This one basically measures the model's own confidence. It says, okay, I think that blurry shape in the distance might be the delivery driver, but the lighting is terrible, so I'm only 30% sure.
By combining the scores from these three judges, relevance, informativeness, and uncertainty, the AHA model gets a much more nuanced understanding of the video and can make smarter decisions about what constitutes a highlight.
But there's another huge challenge when you're dealing with streaming video, especially long videos: memory. The AI has to remember what it's seen and what its task is, but it can't just store every single frame forever. It would run out of memory.
This is where the researchers came up with another brilliant idea called the dynamic sync cache. It's a way of managing the AI's memory that mimics our own long-term and short-term memory.
So the sync part is like long-term memory. The AI takes the initial task, find the package, and locks it away in this sync. It never forgets its core mission.
Then the cache part is like short-term memory. It's a sliding window that only holds the most recent few minutes of video. As new frames come in, old ones are dropped. This means it always has the recent context it needs to understand the present, but it doesn't get bogged down trying to remember every detail from an hour ago.
This combination is incredibly efficient. It allows AHA to process a video stream of any length. It could be hours, days, even indefinitely, without ever running out of memory.
Okay, so the theory sounds great, but does it actually work? To train this, the researchers needed a massive amount of data, so they built their own dataset called the Human Intuition Highlight Dataset.
They took thousands of YouTube videos, and to figure out what humans thought were the highlights, they used YouTube's own most replayed data. You know that little graph you see on the timeline? The parts with the biggest bumps are the ones people rewind and watch over and over.
That's a really clever proxy for what's important or interesting in a video. They use this data to train AHA to recognize what moments people are likely to care about.
And the results were fantastic. AHA achieved state-of-the-art performance. It was better at finding highlights than previous models, which is impressive enough. But here's the kicker. It even beat models that got to cheat by looking at the whole video in advance.
That's incredible. Our live commentator with no script and no knowledge of the future is actually doing a better job at identifying the key moments than the analyst who got to watch the whole game tape.
And they didn't just test it on clean web videos. They threw it a curveball, a long 20-minute video from a real robot navigating a building. The footage was shaky, sometimes dark, and messy. They gave it the task, what objects are in this room?
And it worked. AHA was able to successfully identify the moments where the robot turned and focused on important task-relevant objects. It proved it could work in a messy, real-world scenario.
This technology is a huge step forward. It's not just about making better highlight reels. Think back to that disaster response robot. With AHA, it could be exploring a building and send a real-time alert to a human operator saying, I just saw something that might be a person, or this looks like a structurally weak point.
Or think about home security. Instead of scrubbing through hours of footage, you could just ask, show me when the cat knocked over the vase. And it could find that specific moment in an instant because it was flagging highlights as they happened.
The paper AHA provides a robust, efficient, and impressively accurate way for AI to understand video in real time. It's a foundational piece for building intelligent agents that can operate and reason in the real world as it happens.
It's a real aha moment for the field. And that's our paper for today. Thanks for tuning in to Daily Papers.